So there is a mean value theorem that you can apply to integrals, and if f is continuous on AB, then there exists a number c in AB such that, and notice that we have f of c equal to the f average, which is equal to the formula we just used, or that is, you can take the b over minus a and multiply it to f of c, and you'll get the same value as these two things. So this times this is equal to that. And so what does this look like in practice? So since they're giving you a problem, I guess they're starting it, since f of x is equal to 1 plus x squared, I think this is from the last equation, and it's continuous on the interval. The mean value theorem says there's a number c in negative 1 to 2, the closed interval 1 to 2, such that all of the other stuff holds true. So what it should say after this is from negative 1 to 2 of 1 plus x squared dx is equal to f of c times b minus a, which is 2 minus negative 1. Okay, and so this says this thing, negative 1 to 2, 1 plus x squared dx is equal to f of c times 3, right? Because we figured that out a minute ago. This is a c, by the way. Let me write that neater for you. Okay. Now, when we did the integral of this thing, the whole answer came out to be 2, right? So if I divide this 3 over to there, we can solve for f of c again, and we'll have the following: 1 plus x squared is equal to the 2 value. This is your f of c. It's equal to the average value, the f average. This is f average, f av. And so if we want to solve this, we can just subtract the 1. We have x squared is equal to 1, or x is equal to plus or minus 1. Now, there are two values that work for this, because they both follow the interval. And so you can kind of see that, yes, the mean value theorem does hold true here. Okay, so that's that one. And then show the average velocity of a car over time, t1 and t2 during its trip. So some things to note. We have the change in s over the change in t, and that's going to equal s of t2 minus s of t1 over t2 minus t1. Why? Because these, oops, I put t1, because this is just literally the slope formula, and that's how the displacement of the car over time. And so we can find the average velocity is going to equal 1 over t2 minus t1, the integral from t1 to t2 of the velocity of t dt. And then this is actually equal to the integral from, to 1 over t2 minus t1, integral from t1 to t2 of s prime of t dt. Okay. And so if we use the net change theorem, then this is going to be 1 over t2 minus t1, s of t2 minus s of t1. This is just literally plugging in the definition of the integral for this thing, right? We just subtract the s of t values and of the derivative, and we get whatever the integral value was. And then this is actually s of t2, s of t1 over t2 minus t1, and that is the average velocity of the car. So that's how we show the average velocity of the car over t1 and t2 is the same as the average of the velocities during the trip. So I hope that was exciting. I'm happy you guys made it all the way through the class. Let me know if you have any questions. Don't forget you have the final. You cannot retake the final, and it cannot be taken late under any circumstances because I will be entering grades very soon after it is due. So make sure you guys reach out to me if you need help. Thank you guys for watching. You've been great. Take care. Have a good day.